Okay, so welcome back, and now we're going to do an example of using the second derivative test to find the extrema for this function. Okay, so the first thing is as usual, we want to find the critical points. So we're going to take the first derivative of x, which is going to be 5x to the fourth minus 15x squared, and we're going to set that equal to 0. And so if we factor this out, we get x squared times the quantity 5 times x squared minus 15. Actually, we can take out a 5, so let's factor out a 5x squared. So that means we'll have an x squared here, and this will be a 3 there, is equal to 0. Okay? And so now the critical values happen when x is equal to 0, okay, or when x is equal to plus or minus the square root of 3. Okay, so those are the critical values. So now what we're going to do is we're going to use the second derivative test. Okay, and now again, we're interested in really whether it's negative or positive. We're not really interested in the value of the second derivative, just whether it's negative, positive, or 0. So let's find the second derivative of x, and so the second derivative is going to be 20x to the third minus 30x. Okay? And so all we're going to do is we're going to evaluate this at each of the critical points, critical values. Okay, so if we put in 0, so let's do f double prime 0, that's an easy one. You get 0. So in this case, it's inconclusive at 0. Okay, so let's put in positive square root of 3. Okay, well, positive square root of 3 will give us what? Okay, positive square root of 3 is going to give us positive, what, 60 times the square root of 3 minus 30 times the square root of 3, which is going to give us a positive number. Right? So that's going to be positive. Now, what about negative? Square root of 3. Well, this is going to be a negative 3, or excuse me, that's going to end up being 60 times a negative square root of 3. So it's going to be a negative 60 times the square root of 3 minus, what, 30 times a negative square root of 3. So this is going to be positive. So we'll end up with a negative 60 times the square root of 3 plus 30 times the square root of 3. So we're actually going to get the same value, but it's going to be negative. So this is going to be negative. Okay, so now based on this, here it's inconclusive. Okay, here we have a local minimum, and here we have a local maximum. Now, if we wanted to investigate this further, we would need to go back to the first derivative and find out what's going on either side of that point. Okay? It might be an inflection point. So let's do that. So let's go to the first derivative test, right, at 0. So what we're going to do is we're going to look at we want to look at negative square root of 3 to 0 and 0 to the square root of 3. Okay, we could just go from negative infinity to here because, again, remember, it's telling us it's concave down. Okay, so here, what do we have? If we look at 0 to the square root of 3, what are we going to have? Well, let's choose 1, or negative 1 here, and let's choose 1 here, because square root of 3 is a little more than 1. Okay, it's almost closer to 2. Okay, so let's use negative 1 and 1 as our test point. So if we plug in negative 1 here, what do we get? We get positive and we get negative, which gives us a negative. So then we'll get a negative for this one, for negative 1, right? Because this is going to be positive and this is going to end up being negative, so negative times a positive is negative. And then if we put a positive 1, this is going to be positive. This is going to be positive, and so it's still going to be negative, positive or negative, right? So this is going to be negative, this is going to be positive, so we still get a negative. So what happens? It's decreasing, and then at 0, right? And then it continues to be decreasing at 0. So it's increasing decreasing on both intervals. And so there is no local extrema at x equals 0. And of course you can verify that by looking at the graph. Okay? Because it does something like this. So here is the 0. Right there. So it's concave down, right? Like so. And then here would be negative square root of 3, and here would be positive square root of 3. So you can see that it's concave down all the way until you get to this inflection point here, and then it turns the concave up, right? And then it changes back to concave down here. Okay, so again, the graph confirms what we had gotten using the second derivative test. Okay, have a great day.